Hi, Honors Geometry students. Welcome back. Today we're going to talk about the volume of pyramids and cones, and this is going to fall under the Learning Target 3G. I can compute, solve, and analyze volumes of geometric solids. All right, so we're going to take a look here and the entrance question. You'll notice that we have a cylinder hanging out here on the left-hand side and a cone hanging out here on the right-hand side. I want you to assume that the base is the same size and shape, and that the height for both is the exact same. So please take a moment, pause the video, and see if you have a prediction for the relationship between that cylinder and that cone. Okay, hopefully you had a chance to pause the video, and let's check out what's happening with this quick little video clip. That the cylinder was 3 times the volume of the cone, you were correct. All right, so that's going to take us into today's stuff about the volume of pyramids. And it's pretty much the same thing as our prisms lesson. We just have this 1/3 hanging out in front. So our generic formula is 1/3 big B times big H, where big B represents the area of the base. And remember, you can tap on this link and it'll take you over to a Google Doc that has a list of all of the area, surface area, and volume formulas that you will need. And you'd be taking a look at all of these area formulas for your base and plugging that in. As you are starting this, and then big H represents the height of the prism. So from top to the bottom, drop it down at a right angle. As you are beginning, humor me. Please write out 1/3 big B times big H and then replace big B with the area formula for the base. You are less likely to leave something out. Okay, so example 1 says find the volume of the square base pyramid. What do we know about squares? We know that we have right angles hanging out at all of our corners and that all 4 sides are the same length. All of our measurements are given in inches. All right, so it's pointy. So anytime you think about a pointy shape, you're thinking about 1/3. 1/3 big B times big H. We are going to then take this big B and replace it with the area formula for a square. So you can think of it as length times width, or you can think of it as length squared, whatever floats your boat. Okay, our length and width are both 16, so we'll plug those in for L and W. The height of my pyramid from top to the bottom, drop down at a right angle, that's 15. So all that's left is to type that into our calculator, and we get 1,280, and we're dealing with cubic inches as the volume for our pyramid. Cruising along. You'll notice here that we have a triangular base pyramid. And I'm going easy on us to begin with. Notice that the base and the height of the triangle are connected by a right angle already, so we don't have any extra figuring to do. So we're going to start with volume equals 1/3 big B times big H. And we are going to replace big B with the area formula for a triangle. which is 1/2 base times height times big height. Okay. Please make sure, especially at the beginning, that you are writing down 1/3 big B times big H, because oftentimes people forget one or both of the fractions, or will forget a little height and a big height. Okay. If we plug in, we can think of B as 8 and 14 as H. If you flip-flop them, that's okay. Big H is going to be this 17. So we have 1/3 times 1/2 times 8 times 14 times 17, and we end up with approximately 317.3 cubic inches. Okay. Switching gears, now we're going to talk about the volume of a cone. Volume of a cone is pretty much identical to what we were doing before. If you think about 1/3 big B times big H, our base is a circle, so we're plugging in the area formula for a circle, pi r squared. R represents your radius, and H is the height of the pyramid, height of the cone. All right, so here we want to find the exact volume of the cone, so that means that we're going to deal with things in terms of pi. But you'll notice here we have our radius is 7, but we are missing our height. But we do have this fun-filled right triangle hanging out here, so we can think about a little a squared plus b squared equals c squared action. So 7 squared plus b squared equals 25 squared. Okay, we have b squared equals 576 when we subtract 49 on both sides. And we have, when we square root, we have that our missing height is 24 meters. Okay, if we plug into our volume formula, 1/3 pi r squared times h. 1/3 pi times 7 squared times 24. We want things in terms of an exact value, so we don't want to type in pi into our calculators. Instead, we are going to multiply together 1/3 times 7 squared times 24. That gives us 392. We tack a pi onto the end, and we are dealing with cubic meters. All right, last one. Here, very open-ended. We want to sketch and label a cone with a volume of 100 cubic centimeters. We can pick any dimensions that we want. We'll plug into V equals 1/3 pi r squared times h, and I'll make V, my volume, 100. All right, so any values do I want. I'm going to start by multiplying both sides by 3. I'm then going to divide both sides by pi. And that gets me to approximately 95.5 is equal to r squared times h. Now I can pick anything I want. I'm going to choose r equals 1 because I'm lazy. And 1 squared is 1. So h must be 95.5. So if we get our sketch going, we have a tall, skinny cone where our radius is 1 and our height is 95.5, and we're dealing with centimeters. Okay, it's now time for you to check this out. We're taking a look at section 6.5. We'll be on page 333. You're going to take a look at 1 through 11 all and 13 through 23 odd. You can either do this on Notability or on Class Kick and follow it up with the formative. All right, I will see you online. Bye.